Okay. We're looking at basic ideas of measures of variation, right? So far we had measures of center. So measures of center were things like means, medians, modes, and mid-ranges. We're going to get two major measures of variation. One is called the range. And the range is a really simple idea. So it's just the distance between the maximum and minimum of a data set. So we're going to work with a small data set for the examples today. I'm going to say I have one with 287, 216, 260, 291, 210, 272, and another 260. Okay, so this is my small data set. So to find the range, I have to find the minimum value, which looks like it's 210, and the maximum value, which looks like it's 291, and I have to find the difference between them. So the difference between 291 and 210 is 81. So the range here gives me an idea about, like, if I have the entire data set, how far apart are the numbers at their furthest point. So that gives me a quick way to get a measure of variation. It's not very descriptive, but it's a kind of fast way to compare the variations of two different data sets. What we tend to use more often, though, is what we're going to call standard deviation. Okay, so standard deviation is basically a unit of measurement. A standard deviation is a unit of measurement that we can use to tell how far a particular sample value is from the mean of that sample. So if a set has a large standard deviation, it has a high level of variation. If it has a small standard deviation, then its level of variation is very small. There is a formula for this, and we're not even going to break this thing down. It says that if I take the sum of the difference between each data point and the mean, and I square that, so that's the sum of the squares of the residuals, and divide that by n minus 1, so that's 1 less than the size of the data set, this gives me the standard deviation. We're not going to go into great depth as to how that comes to be. That's for somebody else in a later course. And in fact, you're never actually going to have to use or memorize this formula, because this thing is built into your TI-84 calculator, and we're going to leverage it to calculate the standard deviations that we need for this course. Okay, so here we have our calculator. We're going to enter in our small data set that we used earlier. So we have 287, 216, 260, 291, 210, 272, and another 260. So our little tiny data set is there. Now to calculate the standard deviation, we're just going to use the one variable statistics. So I'm going to go back to the main screen, type stat, calculate, choose number 1 for the one variable statistics. Okay, so my list L1 is already in the list. I'm not using a frequency table, so I'm going to skip the frequency list and just calculate. And if I look down here, this little SX here, so about the 4th entry down is SX. That is my standard deviation for my sample, and it tells me that that thing is approximately 32.1, right? All right, so just to give an idea of how this works, the mean was up here at 26.57, so about 256.6. If I go 2 standard deviations to the left, which is going to land me about 192.4 of the mean and I go 2 standard deviations to the right, is going to land me around 320.8. That would be the range that I would expect to be able to find values in for this population. If I had something that was less than 192.4 or more than 320.8, those would be considered unusual values for the population. So, all right, that gives me 2 measures of variation that are usable. One is really easy to calculate. It's just a range that takes the maximum value and subtracts the minimum value and puts up the result. The other is the standard deviation, which uses this wonky formula, which is kind of built into the calculator. And this gives me a unit so I can start to talk about how far apart values are from the mean with some relative consistency in statistics. All right, thank you.